Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Minimum string length after removing substrings. Leetcode 2696. In this problem, we are given a string S consisting only of uppercase English letters, and we can apply some operations to the string where in one operation we can remove any occurrences of one of the substrings A, B or C, D from the string S. We have to return the minimum possible length of the resulting string that we can obtain. Note that the string concatenates after removing the substring and could produce new substrings A, B and C, D. Then in example 1 for the given string output is 2, and the reason for this is first we see string AB, so we get rid of it. Then we see string CD, so we get rid of it, and now our string becomes FCAB. So we again see A and B together, so we get rid of them as well. And finally we get string FC, and we cannot reduce it further, so we will return 2 as an output in this case. Similarly, in example 2, we cannot perform any operations, so the length of the string remains 5. Now, in terms of solution, one of the naive approach can be that we iteratively search for string A, B or C, D, and every time we find such substring, we remove it and create a new substring and start over. And this process will continue until no more string A, B or C, D can be found in the string. And this approach will take O of n square time, assuming there are n characters in the string. Because in the worst case, we can find n by 2 pairs in the string. For example, consider a string A, B, 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 B. So here we can find 4 such pairs. We have to run the iteration n by 2 times. And then removing such pairs from a string will take O of n time as well. So because of this, the time complexity will be O of n square. And now the question is, can we do better? And the answer is yes. We can actually think of this problem like a valid parenthesis problem, where we had to match open and close parenthesis to check if string is valid or not. So think of characters A or C as open parenthesis and characters B and D as close parenthesis. So each time we see the character B or D, we try to match them with A or C. And how can we do that? We can actually use a stack for that. So then we don't have to worry about removal operation producing new strings A, B or C, D, right? So we iterate through each character in the string S, and then we check if the current character is B or D. If it is, then we will try to match it with the character on the top of the stack. So if it does match, we will try to form the pairs out of them and pop the matching character from the stack. Otherwise, we will push the current character onto the stack. By the end of the process, the stack will contain the characters that couldn't form pairs A, B or C, D with the adjacent characters. So the length of the stack will be our answer. So now let's see this in action. So first character we see is A, so we will push it to the stack. Then we see B. We know that B can be a matching pair for character A. So we will check is the corresponding character on the top of the stack is A, and the answer is yes. So we will pop it out and go to the next character. So now we see F. So we will push it to the stack. Then we see C. We push it on stack as well. Now we see A. So we push it to the stack. Then we see C. We again push it to the stack. Now we see D, and we know that D can be a matching pair for C. So we try to match it with the top of the stack, and it does match. So we pop out C from the stack, and then we see character B, and we see it matches with the character A at the top of the stack. So we pop out A from the stack, and now we are done with the input string, and we only have two characters F and C remaining on the stack. So we will return 2 as our answer. So in this case, the time complexity now reduces to O of n because we go through each character only once and try to push them or pop them out of the stack. Of course, the space complexity also now is O of n because now we are storing the characters in a stack, and in the worst case, we can store all the characters on the stack. Now let's jump into the code part. First, let's initialize the stack to store the characters. Then we can iterate through each character in the string. Use string to char array for that. So now we check if the stack is not empty and the top of the stack together with the current character forms a string A, B or C, D. Then we will pop the top character from the stack and form a matching pair. And because we are forming a pair, we will skip the current character as well by not adding it to the stack. Otherwise, if we cannot match the characters, we will push the current character to the stack. And finally, we will return the stack size as our answer. So now let's run this code. Let's submit this code. Awesome. And now the question is, can we do better? And the answer is yes and no, depending on the programming languages, where we can solve this problem in O of one space. For example, in C or C++, where the strings are mutable, we can actually use two-pointer technique and use string as a stack. But in programming languages like Java or Python, where the strings are immutable, this is the best we can get because we cannot modify the string in place. So in that case, the space complexity will anyways be O of n. Now let's look at the algorithm for the mutable string. Let's take two pointers, read and write. Initially, both of them point to the beginning of the string. So we will start traversing the string by the read pointer. Read pointer is actually uncovering or discovering the string. So it starts from 0th position and goes up till the end of the string. And the write pointer is actually used to keep track of the position where the next character should be written in case the string is mutable, right? So for each character that we read using read pointer, we first write that character at write pointer's position. And then we check if this character and write pointer's previous position's character forms a string like A, B or C, D. That means we have found a match. So to remove this, we can actually move our write pointer backwards so that we can write the next character from the read pointer in the next iteration. Suppose we have a string where our write pointer is here and the previous character was A. Then we will move our write pointer backward, and next time suppose again the character that read pointer reads is B and the write pointer's previous pointer was say A, then we will again cancel that out. So we will again move our write pointer backward. But in case we cannot form such string, then we will move our write pointer forward, signifying that we couldn't form the string A, B and C, D. Note that if we have multiple strings in the form of A, B and C, D, then write pointer will be lagging behind read pointer, and the write pointer's position will indicate the length of the process string, and the characters from the start up to its previous pointer's position will mark the reduced string. So we can return write pointer's position as our answer. So now let's see this in action for the current example. So initially both read and write pointer point to the beginning of the string. We don't have any previous position to write pointer. So we move both read and write pointer forward. So now the next character is B. We write this character at write position, that is index 1. And now write pointer has previous position. And now we check whether the previous pointer to the right pointer forms a string like AB. And the answer is yes, because the previous character is A. So we move our right pointer backwards. So now our right pointer will be here and read pointer was here. Now our read pointer comes to F and our write pointer is at index 0. So now our write pointer writes the value F here. Again, we don't have any previous pointer to write position. So we move our write pointer forward without any check. Then our read pointer now comes to C and our write pointer was here. So now we will write C here and then we check if previous character to C forms a pattern like A, B or C, D, and the answer is no. So we move our write pointer forward. So now our write pointer points to position 2. Now our read pointer comes to A. We write it at write pointer's position, that is index 2. Now our string becomes FCA and we see that C and A also don't form the pattern like A, B or C, D. So we move read pointer further. Then the read pointer points to C. We write it at the right position and now we see that A and C also don't form the pattern. So we move our read pointer further to point to character D and write it at right position as well. And current write position and the previous write position forms the pattern C and D. So we can cancel it out. So we move our write pointer backward. Now our read pointer comes to B and we write B at right position. Now our string becomes FCAB and again we see a pattern A and B. So we will cancel them out and move the write pointer backward. And now our string will be FCA, but right pointer will be pointing to this point and this is index 2. So we will return 2 as our answer. So I hope this logic was clear to you. Now let's jump into the code part as well. First, let's convert this string to char array to simulate mutable string. Now we can define two pointers, write and read. We can actually iterate on the string using the read pointer. First, we will assign the character at the read pointer to the position of the write pointer. Now we will try to find the pattern. For checking the previous write position, write should be more than 0. And now we check if current character is B, then previous character should be A. Or if current character is D, then previous character should be C. So in this case, we have found a match and we move our write pointer backward. Otherwise, we will move the write pointer forward to write the new character. And finally, we will return the position of the write pointer. So now let's run this code. Looks like there is some typo with respect to if condition. Looks like I'm missing the parenthesis here because these two conditions should come together. So now let's run this code. Let's submit this code. In terms of time complexity, it is still O of n because we are going through each character only once. In terms of space complexity, it will be O of n in the programming languages like Java or Python. But in C or C++, because they have mutable string, we can actually get to O of 1 space. I hope this video was useful to you. If it was, please like, share, and subscribe. The code link is in the description below. Thanks for watching. See you next time.